this video I'm going to show you how to make or calculate a definite integral using the fundamental theorem of calculus. So the fundamental theorem of calculus says if we integrate a function, say f of x, between the terminals a and b, we get the integral, which we'll call capital F, and we're going to substitute the values, our terminals, in, and they stay in this order. So b is at the top because it's there, a is on the bottom because it's there. And literally when I substitute those in, I end up subtracting. So f of b take away f of a, and this is the fundamental theorem of calculus. We're going to use it to calculate a definite integral. So I'm going to just do a quick example. Let's pick a terminal 2 and 3. We're going to integrate the function x squared, and we're going to find the definite integral of x squared between 2 and 3. So first let's integrate. We get x cubed over 3. Now normally when we do this we plus a constant, and we talked about why we do that in earlier videos. Now let's have a look at what happens when we substitute in our terminals. Well, let's substitute 3 in first. For anywhere where we see x, we get 3 cubed over 3 plus c. And then take away, let's substitute 2 in there. If I substitute 2 in there, I get 2 cubed over 3 plus c. Alright, so now I'm just dealing with some values. Let's expand the brackets. So this is 27 over 3, which is 9. 9 plus c, okay. Take away 2 cubed is 8 over 3. And then I'm taking away c. Look what happens to the constants. Plus c minus c disappears. So in actual fact, when you're calculating a definite integral, you don't need to consider this constant because this will always happen due to the fact that when we substitute in for x, the c, the constant, will disappear. So we don't actually need this plus c. And then we work this out. Well, I guess this is 27 over 3. 27 over 3, if we subtract that, gives us 19 over 3 as our value of the definite integral. Now you can calculate the definite integral of any function as long as you've got two values, one at the bottom of the integrand sign, one at the top. You can pretty much look at all the functions that we've learned to integrate. So I'll just look at another one. Let's just look at an exponential function. I'm going to calculate the definite integral between -1 and 2 of 6e to the 2x with respect to x. So I'm first of all going to integrate this. So when we integrate this particular function, we're going to divide by 2. So we divide by this value here, this coefficient of the x, and we keep everything else the same. So 6 divided by 2 simplifies to give me 3e to the 2x. And we don't need to include that plus c because we know that it's just going to disappear once I substitute the values in. Now I'm going to go ahead and substitute in, and I'm going to keep it as an exact value. Okay, so I'm not going to try and use a calculator to work it out. Let me just move aside so you can see this. Alright, so I get 3e to the 2, I'm substituting 2 in here, 2 times 2 is 4, so I get 3e to the 4, take away, and then I'm now going to substitute minus 1 in there. I get 3e to the 2 times minus 1 is -2. And these two are not like terms, so I cannot simplify any further. And that's pretty much everything you need to know about using the fundamental theorem to calculate a definite integral.